Okay, so number 2, we have another function p, and it doesn't matter, guys, if it's f of x, p of x, g of x, h of x, even t of x. I mean, it doesn't really matter. They're just variables. Okay, and it tells us it's in the form y equals ax squared plus c. If the values of a and c are both less than 0, which graph could represent p? So a and c are both negative. So if you weren't sure what to do here, I'm going to talk about using the equation as it is. But as long as our values of a and c are negative, we can just put it in Desmos and see which graph it looks like mostly. Okay. Now, if you happen to pick the correct values for negative values for a and c, it'll be exact. But you know, what are the chances? I don't know. Okay, so a and c are both less than 0. That means they're negative. So a is negative. And what happens when I make my function negative? It flips over. So that's not right. Okay, so it's going to turn the parabola upside down, so to speak, be concave down or frown. Okay. And then c, if c is less than 0, I'm going to have minus a number. That's going to shift it down that many units. Okay. This isn't shifted at all. It still goes to the origin, so that's not right. This one would just be negative ax squared. This one would just be x squared minus c, because it did go down. This one went up, so this would be x squared plus c. And this, or negative x squared, because it did flip over. This flipped over, so negative x squared, and it went down, minus c. So that's going to be our correct answer. Okay, so let's go see how Desmos might help us do this. So first of all, before I go to that screen, let's pick values for a and c. I'm going to make a equal -1. And I'm going to make c equal, just because I don't want to use the same number again, sometimes it matters, -2. So I'm going to go graph negative x squared minus 2 and see which one of these graphs it would look most like. Okay, so let me erase these x's so that we can come back. Oh, it won't let me. Okay, well, there we go. Let's go see what Desmos, which one it looks like. Okay, so, well, definitely not opening up. Oh, geez, so sorry. So again, I'm going to get rid of that one. Definitely not at the origin. Can't be that one. And if we look again, one it really matches is this one here. Okay, so that's how you can use Desmos to do that. So this happens a lot in algebra and, you know, in other math as you go on to high school and college. A lot of times they want to know if you know what's happening without the numbers. So they'll give you things like in general, and they'll give you an equation with just variables and give you kind of restrictions on your variables. They're greater than 0, they're less than 0, they're fractional, what's happening. So I kind of think about that. I mean, I do think about that, and then I want to make sure I'm right. So I pick values for those variables, and I use that substitution method. If you know how to substitute in like that, you can solve so many problems and verify that your answers are correct. Okay, all right. A link for Desmos. Yay, they're already here. Go there. Start my graphing. All right, so I'm just going to go ahead and type in my equation. So I said I was going to do negative x squared, okay, minus 2. Okay, so let me move this up. So there you go. So which one does that look like? Let's go back. We look here, it's not at the origin. So it clearly is not up here, it's down here. So